Hello, welcome back. So in this section, we'll learn about Docker and we'll see what is a Docker container and let's get started. So I'm sure you've heard about the term virtual machine, right? So what is a virtual machine? So if you see the diagram, you can see that we have certain infrastructure here, and on top of this infrastructure, we have some hypervisor, and on top of that hypervisor, we're having some guest operating system. And on top of that guest operating system, we are running an app, which is basically a virtual machine. For example, let's say this infrastructure is on macOS, and I want to run a Windows virtual machine. Then this hypervisor will act as a core for this virtual machine. It will create all the required codes and the packages for this Windows virtual machine. Okay. So what's a virtual machine? So it's a software emulation of hardware. So we just have this software, but under the hood, we are also having the emulation of the hardware. Okay. And it can run multiple operating system and apps at one time, and it isolates the environment securely. And also another advantage is we can have the snapshot of the saving state, and it is portable and cloud friendly, and it is mainly used in dev testing and servers. Okay. So on the other hand, the Docker containers doesn't emulate operating system. So you can see we have an infrastructure and we have a host operating system, and Docker runs on top of that host operating system. So it doesn't emulate the hardware or the OS. Okay. As it shares OS with the host, so it doesn't emulate it, and it is an isolated environment, and it is a very efficient resource use, and it is very fast for startup and scaling. So once it boots, so it's very easy to, or it's very fast to use. Okay. And it is easily portable and used in dev testing and deployment. Okay. So let's see the differences between this virtual machine and the Docker containers. In the case of emulation, virtual machine emulates full hardware. And in case of Docker containers, it packages app with the dependencies. For the OS instances, it runs full OS instances. But in case of Docker container, it just shares the host OS kernel. Okay. In case of virtual machine, higher resources are overhead. But in case of Docker container, lower resources are overhead. Virtual machines takes much time to start, but Docker containers are faster in startup. And in virtual machine, isolation is on the OS level, but in Docker containers, the isolation is on the process level. Okay. Virtual machine supports different OS version, but Docker containers are limited to the host operating system version. And virtual machines are very less efficient for the microservices, but Docker containers are very efficient for the microservices. Okay. So since we have OS level isolation, so it is more secure. But in case of Docker containers, they are less secure because of the shared kernel. And virtual machines are managed by the hypervisor. On the other case, Docker containers are managed by the Docker engine. And virtual machines are ideal for various workloads, but Docker containers are ideal for microservices and CI/CD. This is continuous integration, continuous deployment. So I have a blog. You can go and check this pratapsharma.io. What's a Docker container? So I have prepared few articles about that. Okay. So as I talked about the kernel level, so here in the virtual machine, the hypervisor acts as the kernel between the guest operating system and the infrastructure. So let's learn what is the kernel. So an operating system comprises of two core components, which is the kernel and the other is the OS operating system's bundled file and programs. Okay. So the Linux kernel underpins an Linux-based operating system like Ubuntu, Fedora, and Debian. But containers depend on the host kernel, making it impossible to natively run a Windows Docker container on a Mac OS host. Similarly, running a Linux container directly on a Windows or Mac OS host is not feasible. So can we run Linux container on Windows or Mac OS? So yes, when we use Docker Desktop, so I can go and show you Docker Desktop. So using this, we can run Docker containers on either Windows machine or an Apple machine or a Linux machine. So you can see I have this Docker running in my system. So you should also go and download this. Please go ahead and download. So we'll be using this in the next lecture. Okay. So if you can see, when we use Docker Desktop, a Linux virtual machine is initiated for us. So this VM subsequently serves as a platform for running our Linux containers. So the process resembles like hardware. On top of that hardware, we have the Mac OS, and then on top of that Mac OS, we have hypervisor, and on top of that, we have Linux VM, and then Docker and container and another container. So this is very less efficient and merely is executing the program within the Linux virtual machine, right? So since we use this Docker Desktop only in the local development, so it doesn't really matter, because in the cloud, we'll be using a cloud machine where we don't really need Docker Desktop. Okay. So running application in Docker containers. So in order to operate our Flask app within the Docker container, we need to create a Docker image containing all the essential dependencies for the app, excluding the OS kernel. We don't really need this. Okay. but we need Python and we need the requirements for this Python project. And also potentially we may need this Nginx or Unicorn. So these are basically a web servers. We'll discuss this in the deployment section. Okay. So now let's learn what is a Docker image. So a Docker image is just a snapshot that encapsulates all the necessary components to run the containerized application. Okay. So it includes source code, libraries, dependencies, tools, and other resources required for the application. So we have pre-built images and we also have a Ubuntu containers. Okay. So many pre-configured images are available, some of which contain complete Linux distribution like Ubuntu. So these images can include various software stack and facilities. Okay. So here is how we will define a Docker image. So I will guide you through this in the next lecture, how we should create all this. So this is a Docker file. So basically the process would be from this Docker file, we'll be building this Docker file, and based on the build, we'll have this Docker image, and we will run this image and we will create a Docker container. Okay. So here, so in this Docker file, we have this Python image. Basically, this is an image, and we are exposing a port on that particular container, and we are having this /app as a directory, work directory, and then we are running this pip install Flask, basically, which will install the Flask package in the application, and it will copy all the resources, and finally, it will run Flask in the host and in this certain port. Okay. So what's the benefit here? The separation of between Docker images and container offers a notable advantage. Once an image is created, it can be easily shared and deployed. Okay. So images can be shared with developers and sharing consistent environment. Images can be deployed to servers, simplifying setup and reducing the consistencies. Okay. So you can go through this article and read about it more. So basically, this is what a Docker container is. So I hope I'm able to help you with understanding a basic of Docker. I will post a link to more detailed blogs about Docker containers, which will help you understand the working of Docker, Docker images, Docker container, and virtual machines. So this is it for this session. Hope to see you in the next one. Bye-bye.